Hey everyone, have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Last video we talked a little bit about a couple of things that came up, and we were able to encrypt our message, which is great. So we were able to encrypt our message using this algorithm, and now we can encrypt it using any shift of a cipher, which is nice. And it's really quite simple to do because we made our functions that are able to do everything for us, and we just have to create this for loop to go over every character in the message and create our final string, which is this encrypted message. Again, we can take a look at it. So that's half of the equation, and we need to encrypt the message initially. And now the next thing is this looks like gibberish, right? So if I'm the receiver of this message, I need to be able to decrypt it and read it back into regular language, into English, right? But the first thing I'm going to do is I'm going to talk a little bit about what we've done so far and how it can be improved. So the one thing we want to do, and we've been doing this quite a bit, but I think it's a good way to learn new skills, is to first, I already know how to solve this, but what's a better way? So here, you saw that we did this thing with the characters, right? We had to check for these individual characters being in there. And this solution works, but it's a bit time consuming. And the reason it's time consuming is that every time it goes through this, every character in this message, it's checking if it's inside of these three values, which is really something we want to avoid, right? I mentioned it up here, but if you have to check every single value, so here we checked every single letter if it's equal to a value, that's a bit time consuming for a computer relative to other things. So the reason we did this, if you remember, is because we tried to encrypt a character that we didn't have inside of our dictionary, right? So the character, let's say, was exclamation point, and we wanted to do this, and oops, not encrypt character, encrypt letter. That would help. And it comes up with this key error. Basically, it doesn't know what this key is. So if we didn't have this line in here, let's take it out just to show us again. If we didn't have this key in here, line in here, it would complain about a key error because space wasn't in this dictionary. Now, what's a couple of ways that we could try to fix this? So this was the one way that we took in fixing it. We just checked if it was in a certain number of values. And this worked because in our string, there's only a certain number of non-letter values in our dictionary, right? These are still characters, but it's a comma, it's an exclamation point, and it's a space. The only thing, though, is first off, there could be a lot of other punctuation that we're not accounting for in here, right? So if I tried to look up, for instance, a period, it's not going to be able to find the period, right? Or a question mark, it's not going to be able to find the question mark. And this logic won't work, right? So if I said message upper plus question mark, so I'm adding on question mark just to the very end of that message, it's going to come up with an error because I don't have it here. Now, yeah, I could just go through and add this every single time and it will work, but it would be nicer if there was a more elegant solution than just knowing every single possible thing that someone might pass in that isn't a letter. I'm going to go back and talk a little bit about exceptions. So first I'm going to solve the problem like I normally do. I'm going to solve the problem using the new concept and then explain the new concept. In this case, instead of doing this, let's go back to where we just had this, right? And remember, this gave us a key error. And it says it doesn't know what a space is. So instead of running this, doing an if statement, I'm going to use a try and except clause. So I'm going to say try to run this line of code, except key error, and I'm going to say encrypted, I'm going to first say pass, like we did last time. So this is going to print out this gibberish looking line with no spaces in it. And this is similar to the original gibberish looking line with no spaces in it. So if you look at it, this is the same kind of gibberish looking line with no spaces in it. Okay, so that's what I'm going to explain this in a second, but similar to before, we talked about when we did this the first time we did pass and then it didn't have a space. So we're going to just do encrypted letter equals space. And now we end up with the same result that we had before. So we're going to talk about two things. A, what the heck did I just do? B, why is it better? And C, just a couple of additional things. So this is called a try except block, and it's called error handling or exception handling. In Python, these are known as exceptions when these things come up. And there's different types of exceptions, and we've actually seen a few of them as we came on. There's key errors, value errors. There's a bunch of different types of errors that you could potentially run into. A type error that you could potentially run into when you're running your code. And what try except blocks will do is it will allow you to handle those errors, error handling, in a way that makes sense, right? Now, in Python, actually, exceptions aren't necessarily bad, and errors aren't necessarily considered bad. They're just seen as exceptions to the rule. And you can use try and except blocks to handle situations that are similar to the one that I'm describing. Now, how does this work? Basically, we have this line of code here, right? This has an error. If I write try and colon and then put this inside of the indent, it will try anything in this indented block, and it won't try this. So if I do print hello, it tries this, and then nothing happens if it doesn't work, right? The reason is because we need an except clause. So we say except print hello. So what it's going to do is going to try this. If it works, then great. Ben's your uncle. If it doesn't, then it will go to this except clause. So if I run this, it's going to print hello because there was an error that came up here when I ran this. However, if I put a regular letter in here, nothing happens. And in fact, I could just print this out, and it will print out the letter that would have came out. So this works because this is valid. B is inside of that dictionary. There's not going to be an exception. It works. But if I use exclamation point, which is not inside of the dictionary, it goes to this other line of code, hello. Now this is what we did here. We enclosed it in this try except block, except we specified the type of error. The reason we did this is because we only want to catch this particular type of error, meaning we don't want to catch any error. We want to catch this specific one. Now, there's a couple of reasons why you might want to do this. I'll give you an example here. If we have this line of code and then we have something like 3 plus S, this isn't going to work, right? This is a type error, right? But so just to show you that this isn't going to work, just so we're all clear, if I do 3, there's a lot of things in Python that don't look like they will work, but they do. But this one doesn't. This is a type error, and it says unsupported operand types for plus, int, and string. So this is a different type of error. The other error was a key error. This is a type error. And you can imagine there's many different types of errors that you could have, right? But in this case, you have a type error, and this is what you were intending to happen. But if I just run this, it's just going to come back with hello, right? Because it tried to run the code here in this indented block, and it came up with an error, which it went into here. But I'm catching every type of error, right? I probably don't want to do this because this is wrong. This wasn't the right code that I wanted, right? So I want to make sure that I'm only catching that type of error that I saw before, key error, right? If I run this, it's not going to work in this case because there is a key error. But if I run this guy, it's going to come up with an error. So let me just go back to make it clear. If I just do a regular except here, this will work, right? But it might not necessarily be what I wanted. If I do a except key error, it will only do this if there was a key error. Otherwise, it will come up with the error. So as errors are usually seen as bad, but you might actually want to make sure you see them, right? Because they also tell you something's wrong. If you just catch everything and you just do except, this is known as a bare except, it will take any error that comes up and just do whatever you say to do after it. Usually not what you're looking for. You want to specify the type of error that you're looking for. Now, it's possible that you're going to get another key error somewhere in your code that is not the key error you were intending to get. If that happens, you're either going to have to make your own exception that's specific to that, which is a little bit beyond the scope of what we're doing here, or you'll have to make your own if-then statements. But in general, if you're looking for a particular, so for instance, in this case, there's only two things that could happen, right? We're either going to have, there's only two ways you can get a key error is in these two dictionaries, right? When you're going from letters to numbers and numbers to letters. We already know our calculations aren't going to allow there to be a key error in here if we have an actual number, right? Because of the modulo, it will only be between 0 and 25. It will always come up with a valid number. The only place there could be a key error is here, and we're handling that, right? Okay, so why is that better than the if-then statement? First off, this is faster. And there's a general Python view. And now there's a lot in Python that's like this, right? There's best practices for Python. In Python, one of the principles of Python is it's better to ask for forgiveness than permission. And the reason behind that is it's actually faster to try something and fail and do something when you fail than to check something over and over again. And this is why we call it an exception, right? This is an exception to the rule. Most things that we pass into this encrypt letter function, most characters, we expect to work normally. And then things that aren't letters are exceptions to the rule, and we want to handle those differently. In general, this is faster than checking if each value is in some predetermined number of values, right? I could check if the letter itself is in some set of letters before I do this. But in general, it's faster in terms of how long it's going to take because the computer doesn't have to check every single time. And it's considered best practices to do something like this as compared to what we did in the last one. Now, if this seems like a lot of information to you, don't really worry too much about it. Just know that you can use these try and except clauses to help you out, especially if there are cases where you have errors that you are expecting. And secondly, it's just a little bit of a faster method. Okay, and now while we're here, I mentioned before in terms of incrementing that there's a bit of a shorthand for doing this, and let's just throw that in there too. So now we have this, and this will work the way we intended. So nothing really changed here. Just wanted to take this opportunity to talk a little bit about exceptions in general, because there's lots of them. See, we have a type error, we had key errors, there's attribute errors, value errors, lots of different errors you can see. You could even make your own errors if you want to, exceptions. Talk a little bit about those and talk about how you can use these try except clauses to really help yourself out, especially in this case. This will handle anything that we weren't expecting, so we don't have to check every single type of value, and it's faster. There's a lot of upsides here. Yeah, just wanted to take this opportunity to talk through it. Okay, so now we have a little bit better version of our encryption function, and we can get rid of these scary looking errors. Gotta admit that that red syntax highlighting is a little bit terrifying. Yeah, so in the next video, we're going to talk about how we're finally going to be able to decrypt this message, which means go back to the original language. And it's actually not that hard. We've actually done everything we need to do. So all the work we've done up till now, it's been a bit of a slog, but now that we're here, it's going to be really easy to go back in the opposite direction. So looking forward to that, and then we'll finally have a way to use our ciphers to encrypt and decrypt messages.